So I want to talk about building fast applications, and that's the reason are twofold. Firstly, because if you know about performance, if you know about your app, like if you know about performance, you know your app very well. You know every ins and out of an app, and you learn deeply into your PHP code, and your app, and your framework, or whatever. But most importantly, I want to talk about a fast application because it's fun. Like I love performance. I love to make things go more fast. Um, and short about me, I try to do good things at Eneba.com. It's basically a website where you buy cheap video games. I'm also a certified Symphony developer. I'm part of the core team, I'm part of the care team, and I'm doing my very best to run PHP meetup groups in Stockholm. Also, I do a lot of open source. I started my open source career on a conference just like this. It was back in 2015 maybe. PSR Cache just came out. So I'm like, cool, me and my friend like, hey, let's build implementations about this. Let's build a Symfony bundle about this. And we had such a fun time at the conference, we had such a fun time the month after, so this quickly snowballed into a lot other things. My favorite here, I think, is the NSA. NSA, I built a package at the time, Snowden leaked a lot of documents, so NSA totally violates your class privacy. Accessing private property is a method, easy with NSA. And I do think I'm the most downloaded PHP maintainer. Like packages I've created, packages I maintain, have over 100 million downloads a month, and plus the Symfony stuff. So I don't know who else would be more downloaded than I am. Of course, doesn't make me a good maintainer. Like it just makes me, like we talked about bus factors this morning. Anyhow, let's start with the talks. So I see this on the internet, I see this on Twitter, the passive-aggressive guy in your office, he often says like, oh, don't use a framework, it's slow, blah, blah, blah. But what does it really mean? Like, first of you, like, oops, sorry, how many of you are using a framework? Like, that's basically all of you in the room. And now I'm asking the question, like, what is a framework? And I require some kind of, what is a framework? Yeah, I singled out you, that wasn't, my point is, it's not clear what a framework is nowadays. Like 15 years ago, I started with Send 1 or Symfony 1. And at that time, a framework was basically every single class you can possibly think of. And like, you just download everything, and it was in the framework and wired together very nice. Because we didn't have Composer, we didn't have any ways to share classes. We have this phpclasses.org. When someone wrote something cool, they published the class, and then you went there, copied it, and put it in your application. That's like, but that's not where we are at the moment, right? That's not a framework. If you download the latest Send Expressive or latest Symfony, you basically have 1 or 2 or 3 classes that creates a structure, they create a set of rules, they just guide you like how to write a good code, starting from almost nothing. So a framework is just guidelines and set of tools. So the passive-aggressive guy, what does it's always a him, it's never her. The passive-aggressive guy, what does he mean when they say something like this? Let's dig in, like frameworks, we don't know what it is, it's not frameworks that are slow. Let's dig into performance. Let's talk about performance. And there are 3 rules with performance. These rules are always true. And rule number 1, just buy a better server. Like, hardware is always much cheaper than software and then us like developers. Rule number 2 is to use Varnish, and most people do this. It's awesome, and the idea is basically let Varnish handle 95% of your traffic, and that's like your application is never actually on the real load. This is not a Varnish talk. I won't talk more about Varnish. If you didn't know about Varnish, now you do. Go home and Google it, and you'll be super happy. I'm going to talk about rule number 3. And this is the actual way to speed up execution of your applications. There are no other way to make your application run quicker. Do you know what this is? This is, someone says assembler. This is basically assembler, and this is basically echo hello world. And the idea with PHP is you write PHP code, and eventually it gets compiled down to machine code just like this. And every of these lines is a tick in your CPU. So if you have a 3 gigahertz CPU, that means you can run 3 billion of these lines per second. And the idea, I want to tell you, the more ticks you have, the more slower it is, right? So how can we remove ticks? How can we remove code, etc.? So this is the research part of my talk that I want to share with you. Going down in some history. Here I have an Hello World application in different versions of Symfony. And it's not 100% fair because I didn't manage Symfony 1.4 to run. It's bad, but it's not this bad. They run in dev mode. But I wanted to see a trend there. I wanted to see, to have a Hello World application in Symfony in these versions, I first require like 2,000 lines of code. And then we, at Symfony 4, we got down to 1,500 lines of code. And it's a down-pointing trend. And also the number of function calls, number of memory, number of time also went down. And basically, less code you execute, the quicker it is. That's the point I'm trying to push in you. From Symfony 4.4, the community really understood what this is all about. So we kept an eye on this to make sure we keep these numbers low. What you can learn from this slide is basically, it also doesn't really matter. More lines of code is worse, of course, but it also matters which lines of codes and which function calls, because a PHP function calls eventually is C code, and C code also have like some function calls, a lot of C code, some a few C code. So we have kept an eye on this for a while. But this is, of course, Hello World applications. And you can argue it's a bit overkill to use Symfony for Hello World only, right? Like if our business case was to write Hello World, we would have an application like this. And I will tell you, this is the fastest application there is for printing Hello World. Like, and the idea is, the closer your application is to this, the faster it will be, right? But unfortunately, at least my business case is not to write Hello World as quick as possible. My business case is something differently. So we need to figure out what our application is doing. The generic answer of this is, of course, whatever you get when you start a new Symfony project. That's basically, it's good for the most things. You can build anything on top of it. But we're here hunting for performance. We're hunting for milliseconds. So let's figure out, like, how can we make this more performant? Let's figure out what our application is really doing. As an example, I wrote a application for redirects. This is the full application. I just, like, we have this big URL, I want to shorten it. This is the full application for that. And what I'm doing here, I'm just reading some super globals, I'm doing some string manipulation, and then I'm sending a header. And you can argue that having a framework for this was obviously overkill, right? And you can also make the argument that doing this in PHP could also be overkill. If I was a better Nginx engineer, I'll probably do this in Nginx, but PHP is my tool. So whenever you're starting new, you need to figure out where on this scale is your application. Is it over here with my redirect application? Or is it way, way, way past over there using forms and stuff, super complicated? Like, where are you at the scale? And to figure out where you're at the scale, I like to play a game called Do You Need This? Bear with me. Say, do you need security? Say you're on a private network. Do you actually need security to verify headers or do some complex? Or you just have a network layer taking care of this? Do you need forms? If you're just writing a microservice, do you need something as complicated as forms? And if you only got a few routes, do you need a router? Like the Symfony router is the fastest router there is, but it's still slower than no router. And do you need a kernel? If you have a small code base, do you actually need a kernel? I love dependency injection just as the next person, but do you need it if you only have 10 classes? Also, do you need classes? Like, do you need HTTP? Like, if you have a microservice just doing CLI, writing the queue, do you need HTTP? And if you need HTTP, do you need HTTP Foundation or you're happy with superglobals? Like, you should know, like, it's basically impossible to get the IP address in a reliable and secure way from superglobals. And that's one of the features of HTTP Foundation. But maybe your application doesn't care about the IP. Like, my application don't. So, like, why? I don't need HTTP Foundation. I could be happy with just using the request URI. And the messenger component, one of my favorite Symfony components, reads and writes to different queues, has a lot of abstractions to make it easy for you to switch from AMQP to SQS and to Redis. But it's a lot of abstractions. It's a lot of tools that help you. But just using, the AMQP extension will, of course, be much, much quicker. And also, how often are you switching around message brokers? Same thing with Doctrine. Doctrine is great, But if you have a microservice, you have 1, 2, 3, maybe 4 queries to read this and update that. I'm like, Google how you do those queries without Doctrine, and you'll be fine, because Doctrine adds a lot of convenient abstraction layers, but maybe you don't need them. So what I'm trying to say, for me, is a balance. Like every time I add a new feature, every time I do a dependency, I can choose between being here, like I have a lot of well-tested libraries, I know take care of all the edge cases, they provide nice and comfortable APIs for me to work with, but it will lead with more code. I develop super quickly, of course, because this is what I've always been doing, but it will be more code executed to just do my hello world, like my application. Or I can be all over here when I write all the code myself. I take care of only my edge cases, and sometimes work with tricky APIs like the PDO or MQP extension, whatever, but there will be less code. I will write it very slowly, but it will be less code, and it will execute way faster. So it all depends. And most of you also working with a team, even though that you are the perfect engineer, you can figure out all these tricky edge cases, but how about your team? Your team obviously sucks, right? So like, how can you maintain this in the long run? So this is the balance you need to consider, not only for you or the business case or the application, also maintenance and the team. Cool. Um, I'm hoping I'm talking way too fast, and I see someone yawning on the front row, but I would like to, some kind of feedback and interaction from you. No worries, man. All right, so I will take you through an example application now. I want to build something. I want to build something really small, way less complex than the Symfony skeleton. And I would encourage you next time you have a like, hey, guy, build a small microservice, please. Next time, try to start from nothing. Try to open an empty index.php file and start from there, and like challenge yourself. And obviously, you'll be slower writing it, but there will be more performance, and you might learn things. So I want to talk now for the next few minutes, and I've been doing versions of this for 15 years, writing code like this, and I'm settling in something I like a lot. It doesn't mean that you should like it a lot, but this is what I will go over with you. I have open sourced it. I haven't put it here as a framework that competes. Like, it's more of a, if you don't remember exactly how I did things, the slides were a bit too complicated too quickly, or I hid something in the slides. Like, there is a reference point where you can see what I actually are doing. Also, I will share the slides later, and I'm sure that the video recording is available as well. Anyhow, we started from beginning, we started from scratch. I decided I want to use the middleware pattern because that feels comfortable for a small application like this. So I opened up my index.php file. I decided I want to use HP Foundation because that makes things easier for me. So I create a new request, I create a new response, and all the way down there, I am echoing the body. So executing this index.php file, executing this application, it will look something like this. Not super exciting. Like, this is what we expected. Not super exciting. Anyhow, let's add some content. Let's add some more cool things here. So I decided to define my first middleware. I used an anonymous function. The anonymous function takes a request, a response, and the next middleware in the chain. And what I'm doing here, I'm checking if this is a GET request, then say, if it's not a GET request, say method not allowed. If it is, just continue with the next one. And my next middleware says something like, oh, add some content to it, and then call the next middleware. And then I have a runner to make sure to run my middleware, and I invoke the runner, get a response back, and now, when I print it, ooh. All right? So, of course, like, it makes sense, but I hid a lot of logic in my runner here. So what if, like, I show you my runner. The runner basically takes a array of middleware, and it's an invocable. And what I'm doing here, I'm taking the first middleware, checking that I actually got something, then I invoke the middleware, and I invoke it with the third parameter as a this. So if the middleware is done, I just call this invocable again, and basically it's a loop. I do it over and over with a big stack trace, but yeah. And if you feel a little bit icky about the anonymous functions, slap on an interface on it. That's fine. That's cool. So with this 4 slides I just showed you, you can build a application like this. This is actually a geocoder I built many moons ago. So I add in my middleware, I say I want to add some cache, I want to add New Relic for monitoring, and then I add some security, and then I add my router. Yeah, and obviously I hide a lot of logic in my router, and my router looks something like this. So I just get the URI, I check if it's /local, use the IP controller. And if it's from IP, I also use the IP controller for some reason. If it's just /, use the geocoder controller. So here's when I'm actually starting executing the application code compared to my framework code. And of course, I said it before, Symfony has the quickest browser there is, but this switch statement is of course quicker because even Symfony has a lot of abstraction layer on top of it. So I feel kind of good about myself right now because I built a framework. It's basically only my code. I know basically every line in this application, and I feel like I'm on a roll. However, developing this application is a bit tricky because I have a cache layer here. Because whenever I want to geocode something, I ask Google Maps, hey, what's the address for this IP, what's the country, whatever, and Google Maps likes to charge me money for this transaction. So I added a cache to save money. But when I'm developing, like when I won't see my changes because I have the cache layer. And I want to have something smart. I want to have some different configuration for production and development, right? I don't want to just uncomment this line like a peasant. Like I want to have something properly. So I decided I want to create something, a class that controls this. I call it a kernel. So this kernel should be responsible for allowing me to have some nice YAML configuration. And I also heard about dependency injection. It's cool, I want to add it. So I create my class. In the constructor, I say, hey, give it an environment. Is it production? Is it dev? Or am I debugging or not? And then I have my handle function, which is basically what you saw before my index.php file. Instead of just creating my cache and New Relic, etc., I get them from the container. Then I have them in an array. I put an array in the runner, and then I run it. And then the boot function. Here's where all the extra features and fluff is added. So I first check if we're booted. If we're booted, do nothing. Then I check, do we have a cache container on disk? If we do, use it. If we don't, then let's create a container builder. Let's add a few parameters to it. And then let's load services YAML or services underscore my environment YAML to add the configuration, right? And then at the very end, I just compile it and I dump it to disk so I can use it later. And with this 100 lines of code, I can have configuration like this. I can easily say, hey, this is my services, this is my controllers, this is everything, and I can have different configuration depending on if I'm in prod or in dev. So I feel very happy at the moment. I'm like, this is super cool. Like, I want to add more features. So what if I have a class implementing event subscriber interface, I can add this tag to it so I can find it later and do some changes with it and wire things up properly. Or if I have something extend command, add this tag to it. And so I can add more and more features like this. And at some point, you gotta say, hey, Tobias, I do understand the first few slides you added. The index.php file looks great, but now we are just getting in the mess and boilerplate. I don't feel as positive and nice anymore. And when you have this feeling when you're building your own application, there's too much boilerplate, too much wiring, too much whatever, this is maybe a sign that you have grown out from, we have a super small application, smaller than the generic one given by Symfony, and we're just starting using the Symfony Framework Bundle. Because basically, this is what the Symfony Framework Bundle does for you. And a very early version of Symfony was basically what I just showed you. So if you come to a point where you feel too icky with all the boilerplate, use a framework. But maybe you don't have this is creating a new application from scratch, and challenging yourself and writing good things, but maybe you don't have the luxury of creating new apps. Like maybe you're like most of us that are stuck with a legacy application someone else built for us. So I will try to give you some tips and tricks and ideas how to improve performance in such application. Yes, and you all know the basics. These rules are always true. And there are an order from cheap to expensive. And if you make this generic, it's basically this. So again, I want to stress, hardware is cheap, software and developers are expensive. The if you want to do number 3, it's basically because you ran out of money to spend on your servers. Like this is why, or as we had in our company once, there were no more expensive servers to buy. So we need to do something. So that's like, there are in the priority order, please, yeah. And so I will give you a lot of tips now. I'll go over them, and there's plenty of tips, and I'm sure you know a few of them already. That's why I'm trying to be semi-quick going over these. Again, I will share the slides later if you want, it's something you're interested in and want to look into. All right, should we get started? So tip number 1. This is AWS. The expensive computers is towards the bottom of the list. And but tip number 2, caching, especially use Symfony cache component. It's great. It implements the good PSR6, it implements the okay PSR16 cache, and it has the excellent Symfony cache. And it has adapters for memory, APCU, Redis, Memcache database, whatever you want. And what I would like you to do is to set up a cache chain. And a cache chain is basically saying, hey, go first look into memory, my RAID cache. If it's not there, go to APCU. And if it's not there, go all the way to Redis. Sure, Redis, super quick. We love Redis, but it's still over HTTP, right? Or still over the network at least. So it's slow compared to something you already have in memory. And of course, if you find it in Redis, the other 2 caches will be populated with the data. And this is very helpful for data you need multiple times during one request. Yes, so use cache setups properly. Next thing I want to talk about, doctrine cache. Like, you should always cache your doctrine metadata and the query cache. And these few lines, like years ago when I heard about this, I'm like, oh, I don't use this. I add this to these lines to my code base, and I just shaved off 25%. So I encourage all of you, go home, look and find these lines, and if it's not there, you're welcome. So this is basically, you have on your entities, you have a lot of metadata, right? So make sure we cache that properly so Doctrine doesn't need to look it up every time. Also, we will cache the conversion between DQL and SQL. So this is basically no side effects. The last thing I'm adding here is a result cache driver. Say that you're making a database query and you just want to cache it for an hour. You can tell Doctrine to cache it for you. This is an example I have here. This is my blog, and nobody really cares if you don't see the absolute latest version of my blog post, right? If I delay it for an hour, nobody cares. Maybe marketing cares, but in general, nobody cares. But again, I'm having this mantra, run less code, right? Having Doctrine with all the abstraction layers, they're building DQL, they figure out the good cache key for you, and then you have a result cache for an hour. That takes a lot of code, a lot of ticks. So executing this will be slower compared to if you wrap this around Symfony cache or PSR6 cache, because that's way more direct. It's less code to run. Of course, if you're doing your own caching around this, you need to figure out a good cache key. In this example, easy, I use the slug as cache key. But if you have a complex query, it could be more or less complex to add your cache key. And when we are here and figuring out how to save milliseconds, if you then go about and do an HTTP call, like, those are dead slow, man. Like, what's the point if we're chasing milliseconds here and there if you do an HTTP call? So another example for my fictive blog, I have this widget, right? I want to show you the latest tweets from everybody on my blog start page. And I have a good blog. It has 2 visitors per second. It's fairly okay. But this request takes about a half a second. So on the screen now, read it or not, this is a math thing. If we measure for 10 minutes, and then we have 2 requests per second, it takes a half a second for Twitter to reply. The average call to Twitter will be half a second. No brainer, it's just, yeah. However, if we add some cache on this, I add a Symfony cache interface, and I wrap it around with a callable. Yeah, you see on top, I wrap it around the callable, I fetch data, and I store this cache for only a minute. And now, if I calculate what is the average time to Twitter, like, it's just 4 milliseconds. Even though I had just a minute cache, it makes a lot of difference with HTTP calls. And I'm no mathematician, but I'm fairly convinced that this is better. Another thing you can do with this is obviously if you don't want to pay Google Maps with paid transactions, whatever. Google Maps have cache policies. They say you can cache this for a little while, but not too long because we want money. And you can select if you want to respect that or not respect that, but that's also things you can add on top of this. But maybe you don't need any fancy caching, right? Redis it's cool, but maybe it's too fancy. So maybe you're happy with local cache. I have another silly example for you. Say you have a service that wanna calculate the area of a circle. And of course I need pi, and I can compute pi, like it takes a long time, but I can also just calculate once and save it for the remaining of the request, right? I can be smart about it without adding a lot of extra work and fancy bells and whistles. This will of course make my service stateful, so manage that however you should manage that. More about that later. But yeah, you don't always need to be smart. Do something good instead. And as web developers, like our main responsibility, our main focus is to quickly create an HTTP response. So everything that is not related to response, everything you can do later, please do later. Put it in the background work somewhere. Basically, if someone sends an HTTP request saying, "Hey, can you please send an email to this user?" Like your job is to make sure that this user exists, this user had a valid email, etc., and validate the input, and then that's it. Then you will say, "Sure, I will do that later." And at some point later in time, you actually do it. Similar to Derek, how he does those emails. Anyhow, postpone work if you can postpone work. Another thing you should keep in mind is code generation. It's cool, it's great. You feel like a god if you manage to write code that creates code that do something for you. But it's dead slow in PHP. Like, to create that code, write it to disk, and then read it, and then create your classes or whatever, that's super slow. So that should be done during build time. Just like the Symfony, the dependency injection container is doing. It reads your YAML files, reads your XML file, it builds a lot of PHP file and store that to disk. And that's in build time. So in runtime, it's quick. You're not creating a new class in runtime. So if you do code generation, please do it in build time only. Another thing you should consider is lazy services. Lazy services in Symfony and other frameworks, and how they work is they postpone the creation of objects to when you actually need them. So if you have a big fat service like this, had a lot of big fat dependencies, and whenever you require this, I can create this class and all the dependencies, and it will take forever. And so if I mark this as lazy, I will only instantiate the service when the service are actually being used, as in I call a method on the service. And this is especially helpful in your event subscribers, or how I write my event subscribers. I'm doing something like this. I'm listening to the incoming request, and the first thing I do is say, is this the main request? If it isn't the main request, do nothing. And then I say, is this the API route? If it is, like, then cool. But if it isn't, do nothing. But if it is the API route, then I start using my dependencies. So most of the time, I have not the API route. So most of the time, I don't need any dependencies. So why should I load them every time? So that's why making the dependencies of my event subscriber lazy, it's a very good idea. However, lazy is global. So that means that you make everything lazy. So don't go home and think, I'm going to make all my services lazy because Tobias said so. No, making it lazy technically creates a small wrapper around your service, and that wrapper adds extra lines of code, extra ticks. Sure, we talk about nanoseconds here, but it's not a good idea to make everything lazy. Make lazy whenever you need it. And if you don't want to make a service lazy, like if you don't want it to be global lazy, you can use service subscribers, which basically says, hey, Symfony kernel, I want to have a small dependency injection container, PSR 14, I think, with only these 3 services. These 3 services will not be instantiated until you actually use them. I had this problem at Eneba. So we're using a lot of serializers, a lot of normalizers. So in one application, we have 1,500 normalizers. And how Symfony serializer works is basically it loads your serializer class, and everything is cached, everything is warmed up, all the metadata is warmed up, whatever it can warmed up. But if you need to serialize something Symfony hasn't seen before, it will use the normalizers to create the metadata and build a cache on the fly, which is of course slow. But in our scenario, that's never happened. But every time you instantiate your serializer, we also instantiate the 1,500 normalizers that were never used. So at every request, I instantiated over thousands of files I was never using. So I just made my normalizers lazy, and that shaved off 20 milliseconds with one line code change. So like creating objects is very, very expensive, so avoid it if you can. Cool. Moving on to doctrine. I have a form like this. What I'm saying here is I'm showing a list of all the users that have been created in the last year. And this is the participation part of my talk. So I'm going to ask you, how can I make this better? Yeah, no, someone said cache. That's a great suggestion. Not exactly what I was looking for, but great in general. That's the answer to all my questions, to be honest. So I can be a bit nicer to my database here. I can, instead of saying, give me the users that have been created in exactly 1 year, I can like say, hey, maybe 1 year on a day. Because this will help my database to, like, it will recognize this query I've done before, right? So it can have some internal caching or whatever. But we're not done there. No, no, no. One thing I should do, I look at, when I run this form, I look at the Symfony web, the web toolbar, and I can see this query. It took me 215 milliseconds to execute this query. That seems like a lot to fetch some users. So I'm checking, hey, what happened? So I can have an explain here, and I can see, I don't know if you see, but I'm having over 300,000 users in my database. So the solution is, of course, add an index. And I would like you to, like, how I previously have been referring to database indexes, I've been just going around and say, hey, like, we'll look whatever's slow, figure out why it's slow, add an index. But a better rule of thumb is, whenever you have something, a column in where, then add an index for it. Because an index will create more space, of course, but space is cheaper than CPU, and I'm happy to sacrifice space to get better performance. In fact, when adding this index, it went from 200 milliseconds to less than 1. And that's a price I'm happy to pay every day of the week. Anyhow, we're not done there. This code will fetch, say if I have 100 users in my database that I created last year. So Doctrine says, hey, hey database, can I please get the 100 users? So we go into database, we find the data on the database, we prepare it, we transfer it all the way back to application. Doctrine looks at that, and Doctrine creates 100 objects, and we're using only the email. So we can be smart and just asking for the things we actually need. So we can just ask for, I think this pop up automatically. Yes, it did. We can just say, hey, give me the email. Like, so we don't need to ask for the full user object, all the bloat we have there. We just get the email and show the email. And this also skips the hydration part of Doctrine. Like when Doctrine looks at an array and creates objects, that's the hydration. And that's one of the most expensive things in Doctrine. So if we can not use it because we don't need it, perfect. This, compared to the last slide, this will be way both quicker and take way less memory than before. All right, I'm gonna leave this form behind now, but I'm not done with Doctrine yet. I need to talk about the n+1 problem. And all of you have this problem in your application right now. Some of you have fixed a lot of them. And if you say Doctrine is slow, this is 99% of the why Doctrine is slow, because you have the n+1 problem. And what I'm doing here, I have a web shop and I have a lot of products. So I'm fetching the web shop for this country, and then I'm looping over them and see all the products, can I print a name, please? So this will create one query for fetching my web shops, and then if I have 100 products, it will create 100 more queries to fetch every product inside of it. This is, of course, that's n 100+1 problem. So how to solve this? There's a few methods. You can just include the products in the first query, and that means that Doctrine already have them in the unit of work. But you can also be more clever, like from the start, and not asking for the web shop. Just ask for the products if you need the products. Make sense? Cool. Last thing about Doctrine I want to talk about is data transfers. And like, if you're doing a web shop, you have a product entity and it's bloated with a lot of things, just adding things there. And most of the time, you only need the name or maybe the description, right? So how can you make sure that you don't need to transfer a lot of data back and forth to a database that you don't really need? So there are 3 solutions to this. The first one is partial objects. You can say, hey, Doctrine, can I please give me this product, but I only want the name. So you get a product entity back, but in that product, and if you're trying to use a description, you get an exception thrown at you. which feels icky because you need, not all the product objects are the same, which is obviously bad. So skip that one, but you can try to be clever. What if you create a new entity? You have your normal product with the popular fields, and then you have a product metadata with everything else, which you don't really need. So you have two tables now, and then you only query what you need. Some of you are looking a little bit disgusted by this solution, which is good because I'm building up that point. My third solution, which you should do, is a very underestimated function in Doctrine, is to use the new keyword. And this was, of course, introduced in Doctrine 2.4, which was released like 8 years ago. But how many of you in this room knows about this keyword? Okay, it's like 10 of you. The rest of you, you're welcome. So what you can do here, you keep your product entity just as it looks, but you also create a product model, a simple product model. This is not an entity, this is just a normal class. And here I have my normal things like name and category. So with this, I can query the product table just as normal, and then I can say, instead of giving me a bunch of products back, can you please do a new simple product with these two columns and arguments, and I'll get simple products back here. This is a way for you to say, I only need 2 columns, and it's a way for you to have nice objects to work with afterwards. So, super underestimated feature. Whenever I ask the room, it's always like 10 of you that knows. It doesn't matter how the room size is. But yeah, please check it out and use it. Next up is your index.php file. This, like, by default, you get some sensible defaults, but they could often be improved. Here is a handful of suggestions how you can make things better. You can define your own op cache memory limits. You can say, hey, if I have a file in production, that file will never change. You don't need to check if the file has been changed or not all the time. Like, it will never change, I promise you. And there is some other caches you can configure. There is a link to the Symfony documentation to explain what these really are and what they mean and what makes sense for you. If you use an APM or a profiler, say Tideways, New Relic, Datadogs, and Blackfire, they will probably tell you also like, hey, it looks like your op cache is a little bit too small, or your whatever cache, like increase it. So there are ways to figure out if you're on the limit or not. So yeah, these are sensible defaults. Another thing, even though you have the quickest backend there is, if your front end is slow as shit, your application, your user will still complain, right? They will say this takes forever to load and run. And lucky you, in front end, the same thing is true here as well. Like, just run less code in front end, and it will be quicker. We're backend engineers, we don't care too much about front end. Here's a list of things that you generally should do. Basically, keep small HTML pages, only include the JavaScript and CSS you actually want to use, prefetch everything, do async, whatever, blah, blah, blah. But it's also, one thing I like to talk about is the font display swap. That basically means, normally, when you load a web page, the browser goes from top and say, looking at all the XML, all the code I have there, and then it says some fonts. Browser says, cool, I'm gonna go fetch the fonts, and then it goes loading fonts, and when the fonts finally fetch, they come back, now I'm here, cool. Then I'm gonna continue reading and display the content, right? But with font display swap, it works a bit differently. It just reads from top and then say, oh, there's some font here, I'll get someone else to fetch that. Then I continue and showing the content, wrong font, but I show the content. And when the font is actually loaded, we just swap it in place. So it's a way for you to show your content of your site quicker. I wrote a blog post about this. It was a short blog post, but I did a video like loading with 3G, like show this differences, this is how it looks like and everything. And then I tweeted about it, of course, and I felt happy about myself. And like I said, don't use Google Fonts. That's not the support here. This is the tricks you need to do to make sure this works with Google Fonts. And then not only like maybe a month and a half later, Google Fonts updates so it actually includes font display swap. And I think that's pretty strong evidence that Google reads my blog. Front end can be a lot. Yeah, last thing, cache control. You know, set max age, set it to a year, a long time. But if you use hashes in your file strings, also add immutable. That telling your CDN that this file will never change. Like, doesn't really matter anything. This will never change. There is a project called Webpack & Core that helps you take care of this a little bit because it's just a wrapper on Webpack with a nice interface. Cool. Last thing I want to mention about frontend is Chrome Lighthouse. This is, again, if you don't know, use it, it's great. It's part of the Chrome debug toolbar. Like you have the elements, network, and all the way to the right, you have Lighthouse. Lighthouse tells you what you're doing wrong and how you can improve with accessibility, performance, SEO, and whatever. And it gives you nice reports and charts, and you can there's even APIs you can show my Lighthouse number goes up and down, whatever. Cool. So it's a cool audit tool about for frontend. You know this again, but I will tell you there's actually a fourth one. Lie and cheat. And this is, I'm including this because it's a difference between being fast and feeling fast. Right? There are two vastly different things. A few years ago, maybe you remember, if you're logging into PayPal, you got this, and password and username, you got this, and it says we're logging you in securely for a good 15 seconds. Like what really happened here, they had a very, very slow backend. So they claim that our slow backend is slow because it's secure. All the other websites you're using, they are fast because they're not as secure as we are. So they made their bad backend into a feature. And like that's excellent, right? Same thing with this is an example from Slack, but I think it's Facebook who started with a skeleton loader. It basically shows something, so if your page takes a second to load, if you see this for a second, you don't really, this makes it feel quicker than it actually is. One thing you must do is to profile your applications. Whenever you apply one or two of my tip, you do a profile application first, apply my tip, apply the patch, and then profile application afterwards to see what was the difference. Like, did it get better or worse? And this is very, very easy to forget. I'm very guilty of forgetting this time to time. A few years ago, I created a new patch for Symfony. It was an annotation loader, because Symfony has a JAMA loader, XML loader, but no annotation loader. I'm like, of course, like if we preload the data in annotations, it will be quicker in runtime. So I created that one, super happy by myself. On a conference, I told my friend Titoan, I'm like, hey Titoan, I did this, it's super great. And he was like, is it really? I'm like, yeah, because it loads, it's build time, whatever, it's super great. And he said something I don't forget. He said, show me how better it is. So I'm like, all right. So I profiled my application before, applied my patch, and then profile again. And he was right, it was actually a little bit slower. And like, obviously, it took all my energy away from me for a while. But yeah, like, I shouldn't add things if I don't know they are better. There are many profilers. There are Tideways, Datadog, Blackfire, and basically the same. Use the one you like the most, but use at least one of them. Here's an example of Blackfire. I profiled my application, and it took only almost 2 seconds to render this page. I don't know what it was. Can you tell me why this application is slow? There's some whispers in the front. I didn't quite hear, but I'll give you the people in the back a small hint. Class loading. Loading classes and static resources on disk takes forever in PHP. Sure, Composer is great, it helps you a lot with this, and especially since PHP 7, but it's still not excellent. And I'm gonna prove this point to you with two of the best slides ever been. Not created by me, it's created by Andrew Carter. He once were on stage and say, hey, imagine the HTTP pipeline as a restaurant. So you have a client, like the customer, he goes to the restaurant, the server, and asks for food, he requests a response, right? And the one who creates the response is the chef, and the one who runs around to facilitate this is the HTTP daemon. All right? So this is the HTTP pipeline as a restaurant. So what happens in PHP specifically, the customer enters the restaurant, and the waitress takes the order, and somehow the waitress creates a chef, give the order, the chef makes the food, they give it to the customer, and then the waitress brutally murders the chef. Like, this is insane, right? Like, if we were management consultants, we came to this restaurant and they're like, hey, how can we improve? Like, maybe don't kill the chef all the time. And it takes so much time to just create a new chef and train that one properly. So this is something that we do in PHP. We think it's normal, but yeah. So one way away from this thing is to use the Symfony runtime component. That was introduced by Automatic a few years ago. And what that you can use it for, it's not symphony specific, but what it basically does, it wraps your applications inside an invocable. So if you make sure you never write to disk and you never read the superglobals and you cannot manage your you cannot stateful services, then this application is now very much portable. So you can easily try out React PHP. You can try out Roadrunner. You can try out Swool, or you can try out the new cool Franken PHP just to see how the application runs. And to not read and write to disk, use abstractions instead. That's not any groundbreaking things, right? And also to not use superglobals. That's common practice. So just wrapping this around it, you have an easy way to try out the new cool things that the other consultants are talking about, right? Of course, PHP is not really built for this kind of witchery. Like you need to take care of memory leaks. Common memory leaks are in Doctrine because it builds up unit of work, all the entities are always there. So you need to tell Doctrine after request, tell Doctrine, hey, drop everything and start from scratch. Don't kill yourself, just clean the table, right? Same thing with Monologue, it also has this buffer that builds up. So you need to make sure that you're managing state properly. Or in Symfony, you have this reset interface, which basically says, after I'm done with the first request, reset and then start over. And with this, you can keep your application alive technically forever, but I'm not that trusting. I'm rock and roll, but I'm not that rock and roll. So maybe keep your application live for 100 requests or 1,000 requests, and then just kill yourself and start over. That's way better to kill your chef every 1,000 requests than kill your chef after every request, right? So this will improve performance massively, and you'll be better at managing your resources. So I want to say, frameworks are not slow. It is you as a developer who decides what features you add, you decide what dependency you add, and the more code you add from your request to response, the slower it will be. So it's you who are responsible for this balance. And if you have been paying attention, if you apply all of these tips and tricks, you can easily create applications that respond quicker than 10 milliseconds. In fact, if you really, really want to, and then of course, should you really care? No, this is because of fun. And somebody saying, hey, Tobias, are you sure? Can you really do this, Tobias, have you tested this in production? And yes, I have. Thank you very much. So I'm doing a lot of cool things, also taking care of a lot of legacy. If you think you want to do more cool things with me, I'll be happy to see if there's any room for you in my team. This is the shameless plug that makes sure I can go here. So please click this link to improve my stats.